to upload this recording as well, I can and upload it. If not, then you can just refer to the 18-minute long video that I've already done. But in that video, I don't talk about the boundary conditions and all that at the beginning like I did for this one.
So I think it would be better if you post this one too.
Okay, cool. So thank you guys for the feedback. Alrighty, are we able to carry on now?
Yes, sir. Good to go.
Yes, sir.
Nice. All right. So now we've created our key points. What we are going to try and do is we're trying to create an area, okay? We're trying to create an area in this gap. And how we're going to do it is we're going to draw lines, and then we're going to tell the software that we want an area to be inside the area of the lines that we've drawn. So we're going to draw the perimeter, and then we're going to tell the software that we want to create an area inside that perimeter. So also in the lab handout, there are instructions as to how to create lines. So we go to create. Instead of key points, we'll go lines. Select lines again. And in active code. So the second option. And now it says line number 1 goes from key point 1 to key point 2. Line 2 goes from key point 2 to key point 3. Line 3 goes from key point 3 to key point 4. Line 4 goes from 4 to 5. And line 5 goes from 1 to 6. Okay, all following me so far?
So how do we undo a line?
Undo a line? Okay. Let me just click OK. To undo a line, in create, so in modeling create, there's also an option delete. So delete, and then you can select lines only or lines and below. We'll go lines only, and you select whatever line you want to delete. Once you've deleted, you go back to create and then create line again. Set?
Okay, sir.
Lovely. Okay, now we're going to try and create the slot. Like I said, we're only modeling a quarter of the shape. So this is the quarter of the shape. If you can already see it emerging.
So can you please repeat the undo line? You click on the line.
Okay, okay. I'll do an example here so you can see what I'm talking about. So instead of create, we go to delete.
Okay.
We have lines only, lines and below. I'll select lines only. Then I'll select the line that I want to delete. So let's say I want to delete this line. I select that line, click OK. It's deleted. Set?
Set.
Okay, great. I'll just go and create that line again. Okay. Once you created all these lines, we have to now create an arc between this point and this point using 0.7 as the radius, as the center, sorry. So we'll go to lines again. Instead of selecting lines, we'll go to arcs. And then we'll select the second option, by end key points and radius. Select that option. Now we select key point 6, key point 5. We click OK. And then we click key point 7. And then OK again. You should have this dialog box pop up. You all got that?
Got it.
Yes, sir.
Okay. Now, as the radius, we have to set the radius. The radius of this arc is 0.02. The dimensions are all given in the lab handout, and as well as in the picture in the beginning question. That's where we're getting all these key point coordinates from. Once we've done that, we click OK, and now we've created an arc between 5 and 6 with 7 as the center.
Got it, sir.
So to clearly show the line numbers, we go to plot controls, numbering, key point numbers on and line numbers on. We click OK. If everything disappears, don't panic. Just go to plot and then multi-plots. So now you can clearly see all of your key point numbers and your line numbers. Everybody got that?
Done.
Great.
Yes, sir.
Everybody else still doing, or wait a couple minutes? I want to go nice and slow so that no one gets left behind. Hopefully we finished this whole lab session. Everybody understood what we did, because there's a part 2 to this lab, and that part 2 you have to do on your own. You have to model this plate again, but instead of doing a slot, you have to do a hole. So if you look back at our handout, so part 2 of our lab is, instead of doing a slot, we will do model a hole instead. Sorry, that's a horrible drawing of a hole, but you get my idea. Okay. Part 2 of this lab, we're replacing this slot. Oh, that's even worse, with a hole. Okay, I can repeat the arc. Okay, sure. Right. So I'll just delete this line just so that we can all do it again together. Delete. Right, to do the arc, we'll go up to create, lines, so lines, then select arcs, and then by end key points and radius and rad, select that. Now we select key point 5 and 6, and then click OK. Just 5 and 6, OK. It'll look like it's done nothing. Now you click key point 7, OK again, and now you get this dialog box. When this pops up, you enter your radius, so 0.02. And you can see here, it says the arc will start at 5, end at 6, with the center of curvature, so the radius, the center, origin at 7. Click OK. Guys? Right, so once we've done that, we can now go about creating our area. To do that, again, we're in create, not lines this time, we'll go to areas. Have lots of options here. We'll select the first one, arbitrary. What arbitrary means is there aren't lines that are already in a rectangle or a circle or a specific polygon. These are just random lines. So we're going to select arbitrary and by lines. Now we will select all of our lines. So we'll just pick all of our lines. Once we've done that, we can click OK. You should now have a teal blue area showing on your screen. Everybody got that?
Yes,
Yes,
got
sir.
it.
Okay, good. Right, so what we've done up to this point is we've just defined the geometry. Now we have to go about defining the mesh. Okay. So to do that, we close modeling. We now go to meshing. We select the mesh tool. Mesh tool. In mesh tool, we have first option is element attributes, then smart size, then size controls. In size controls, we will look at area and click set. Okay. A dialog box will pop up on your far left-hand side. It'll ask you to select an area where we want to start applying our mesh. We'll click the blue area, then click OK. Now this option comes up. Element edge length. So what we're essentially doing is we're going to create a mesh that is 2 millimeters, that basically divides the area down into sections of 2 millimeters. So we're creating quite a fine mesh. Once that's done, we enter 0.002. Click OK. All right, everybody done that? Okay, now we've set the size, but we haven't meshed it yet. So we go to mesh tool again. And down here at the bottom, make sure that it's set to areas, quad, and free. Make sure those are selected. They'll be selected by default, but if in case yours aren't, make sure it's selected areas, quad, and free. And then we click on the left-hand side button, mesh, and we select our area. Then press OK. Now you can see it's broken up our element into all of these little grid squares. Right, and that is a mesh. This is a 2D mesh. Okay, before we were using one-dimensional meshes. When we did our beams, those were one-dimensional meshes. This is two-dimensional meshes. We have an X and Y component for each of those little squares. All right. Now, when we define a mesh, bear in mind that the finer your mesh is, so the smaller your elements are, the more accurate your results will be. You can do a bit of research into why that is, but essentially, the finer your mesh, the more accurate your results. Okay, the finer your mesh, the more algorithms and the more calculations your software will run, and you'll get a lot more accurate result. All right. So generally, when we model something and we know where the stress concentration is going to be, we try and put a very fine mesh in that area. For this lab, we haven't done that. We've just applied a uniform mesh to the whole shape. But ideally, we would put a very fine mesh on the point where we think we're going to get the highest stress. Okay, everybody done up to here?
Yes, sir.
Yes, sir. Done.
Okay. Just go to plots and multiplots, just to show the line numbers again. Now we've done the meshing, we can start to apply our boundary conditions and our loads. Okay. So, like I said, we were trying to simulate this like it's a folded piece of paper. We're just trying to simulate a quarter of it. So the first thing we're going to apply is a symmetrical boundary condition. Remember, we halved it along the X and the Y. So we will be applying boundary conditions along the X, so line 1, as well as the Y, line 4. To do that, we'll go to preprocessor, loads, define loads, apply, structural, displacements, and down here, second from the bottom, symmetry boundary conditions. We select that, and then on lines, and we select line 4 and line 1. Once we've done that, we click OK. These S's tell us that there is a symmetrical boundary condition at this point and at this point. So we have successfully modeled a quarter of a full-on plate and essentially cut down our processing time by a quarter, down by 3/4 of what it would have been if we modeled the whole plate. Everybody got this?
Yes, sir, got it.
Set. Everybody else? Okay, good, good. Okay, we've applied our boundary condition, but we haven't applied a load yet. So we'll go back to structural,
Can you please repeat the last step?
the boundary condition.
Yes.
Okay, sure. I'll just delete that. All right, to apply the boundary condition, we go to apply, structural displacement, and then symmetry BC, symmetry boundary conditions. Then select on lines. When this dialog box pops up, we will select line 4 and line 1. With those two selected, we click OK, and you should be seeing little S's pop up on your line 1 and on your line 4. Line 4, they'll be a bit difficult to see, but they are there. Set?
That's thank you.
Okay, no worries. Now we have to apply our UDL, our uniformly distributed load. So we're applying this pressure. So 50 kilonewtons, 50 kilonewtons per meter. So we go to structural displacement, not displacement, sorry, structural, then pressure on lines. We want to apply it on line 2. So select line 2, click OK, and we enter the value. Bear in mind, if we enter a positive value, it'll be going into the line. So it'll be going from right to left. We want to go from left to right. So our value we will enter is negative 50 E3. Then we click OK. You should have a small little red arrow pointing to the right. Everybody got that?
Got it, sir.
Right. So We have applied our boundary conditions, we have applied our loading. So now we're ready to solve. So we close loads. We can close preprocessor. We'll open solution. So solution, solve, current loading system. This will pop up, just click OK. And it'll take a minute. And at the end, if you've done everything correctly, it should say solution is done with no errors popping up.
Solution is done.
Set. Once that pops up, we can close and exit. Okay. Everybody with me up to this point?
Yes, sir.
Yes, sir.
Okay, good. Right, so now we've solved it, we can start extracting results. Once again, the solving part, Mohammed. Okay, so just close preprocessor. So we were already in preprocessor, we just close that. Solution, select solve, current LS loading system. Click OK. And it should say solution is done. Set. Once this pops up, we just close this and close our status command. Now we're ready to start extracting results. To do that, we don't need to go into solution. We go to general post processor. Now, before we can do anything, we have to tell the software what set of results to read. Okay, so we'll go to read results. We select last set. So the most previous or the most recent set of results that we just got, we want to use those to then plot our maximum stresses. So we'll select last set. And now we can go to plot results. So select plot results. We can go to contour plot and select element solution. This window should be popping up on your screen. Once we're here, we are interested in the stress, so we'll go to stress. And you have lots of different options for stress. So far in your course 211, you haven't really talked about combined stresses yet, but in your report, you can talk a little bit about von Mises stress. And what is von Mises stress? Okay, that's for you guys to find out and put in your report. So we'll select von Mises stress and click OK.
Sir, could you repeat that? My network connection went bad.
Same here, sir.
Okay,
Me too.
you able to hear me?
Yes, sir, we can hear you
Yes.
now.
Okay, so have you already selected read results? Read results last set, you already done that?
Yes, sir, done that.
Okay.
We're at element solution.
Okay,
Stress.
so plot results, element solution, contour, element solution. You have lots of different options. You select stress. And of all these stresses, you select von Mises. So it's the fourth from the bottom. Select von Mises.
Okay.
And you can plot, you can decide which one you want to plot. You can plot undeformed, deformed, and undeformed, but we'll only want to look at the deformed shape. Let me click OK. This should be popping up on your screen.
Got it.
Okay, everybody got this?
Got it.
Okay, great. Now, what does this mean? It means we have a maximum stress here, and our maximum stress value is, this is in pascals, okay? So it's 4.9 kilopascals. And our, sorry. This is our minimum stress. Minimum stress. So 4.9 kilopascals. And our maximum stress is 0.45 megapascals. Everybody
So
able to
mine
see?
is a bit different. Mine says 456386.
Of your SMX. SMX.
Yes, sir.
Okay, that's fine. So long as you're in the ballpark, okay? Don't worry too much about it.
So
It's
could
so
you
long
repeat
as
that,
it's,
please? Network connection is very.
oh, okay. Just so long as it's in the ballpark. It doesn't have to be exact. Okay, we'll all
Okay,
get
sir.
slightly different results. Slightly different, but close enough to each other. So like Avnil's got 4972 as his minimum, but when you round it off, it'll be 4.9, and mine will too be 4.97. Yours will be 4.97, mine will be 4.97 kilopascals as well. So there's not much difference really. Okay, guys? Set. So this was the first part of your lab. Second part, you have to try and model this instead of having this straight bit here. So instead of having this slot, you just have an arc going from there to there, and all this is straight. And that's for you guys to do on your own. You're supposed to make the comparison in your lab report. And you will also talk about why is the maximum stress occurring here? Okay. You might want to look at something called crack propagation.
Sir, what property?
You might want to search something called crack propagation.
Crack propagation.
Just look into that. You might be able to include some information there to explain why our maximum stress is here. Also note that the maximum stress point is occurring at a plane that is perpendicular to the direction of the force. Also quite an important observation. So you guys go away, you try to look for the theory to back up why are you getting these simulation results, okay? That's probably the hardest bit about doing FEA or finite element analysis. Once you've done the simulation and you have your results, you then have to be able to make sense of it. So go away, do some research into crack propagation, also the behavior of stress in thin materials. And yes,
Sir, could
remember.
you type those out?
Okay.
Because the network connection, I can't hear bits and pieces of it.
Hey guys, so this ends my demonstration for lab 6. Now I'll open it to you guys. Do you have any questions with either lab 5 or lab 6?
No questions.
No? Okay, guys. Okay, can I clarify what? John, what would you like me to clarify? What exactly? To write in the lab. Okay. Hold on. Okay, yes. So after you've done this, remember to click on save. So just go up to File, Save As, select what you've already saved it as. So mine is 2-on-1 Lab 6, desktop. Okay. Do you want to replace? Yes. Okay. Let me just open up the. Oh, actually, I have 5 minutes left. Do you want me to open a new chat room to discuss the lab report? Okay, sure. I'll just end this meeting and then start a new chat room.